Welcome to video 11 in a series of introductory videos for the InventorCAM CNC programming software. This video's topic is the HSS Xpress toolpath. So the HSS toolpath is a surfacing toolpath from InventorCAM, and depending on the module you purchased from us, you actually either have the Xpress package or the full HSS package. The Express is what we'll cover in this video, and the full HSS toolpath will be covered in video 12 of this series. So let's take a look at the HSS toolpath by going to Add Milling Operation, HSS, and depending again on the package you purchased and the license that you've been provided, you will either have full HSS, which is everything you see here, or just the HSS Express or basic HSS, which is found under parallel cuts, linear, and constant Z. So let's begin with linear. So, as always, we'll choose our coordinate system first. The geometry for the HSS toolpath as a surfacing toolpath is actually surfaces or faces from the solid. So here you're not actually choosing any contours unless you are controlling the toolpath trajectories and all that you'll see in video 12 of this series. But here with parallel cuts, linear, and constant Z, you are only choosing the drive surface. So I'll click on New Geometry. So I will choose a surface that I'd like to machine. In this case, I'm just going to choose this surface right here. Click on the green check mark. Now, how we look at this surface is determined by the area type. Now, if I just hover my mouse over this area type here, full avoid cuts at exact edges. If you look in the bottom left corner, what I'm telling InventorCAM to do is consider that surface to be the boundary conditions and only take the tool as far out of the surface as the radius allows. In this case, you can see that the tool starts and ends just inside the surface, and that distance right there can be considered the radius. So again, the surface acts as a boundary condition. What I would like to do is take the tool right to the edge of the surface, so meaning that the last contact point with the surface. In this case, I will switch it to full start and end at exact surface edges. And now you'll see that the blue surface and the red toolpath goes right to the edge of the surface. Drive surface offset allows me to leave some material behind or overcut the surface depending on what I need this to do. And that's really what it's used for there. Now in this Express package, you could use this as a stock to leave if you were using this as a roughing toolpath. But again, HSS predominantly is a finishing toolpath. Defined by, this is the fact that we're using a linear toolpath. So by default, the linear toolpath will zigzag back and forth in the X direction. I could either change the angle here from the x-axis or switch to line and then define a line by 2 points, a start point and an end point. But in this case, let's just go with 0 degrees from the x-axis. Under Tool, you'll see that the tool selection is similar to all the other toolpaths you've seen in the series of videos. But what's unique about HSS is that it allows us to use any shape of tool, whether a shape tool or a fully defined tool. In this case, we'll go with the 1/4 inch ball nose. So I'll click the green check mark. And again, as a basic toolpath in InventorCAM, we need to provide the fees and speeds of this toolpath. Next is levels. Now in levels, it's a little different as well because as a surfacing toolpath, everything is driven by the surface. So there is no upper level or lower level. There's simply just a clearance area. Now again, depending on which package of HSS you choose, you'll have different ways to define that clearance area. But in HSS Express, I believe it is just a plane in one of these 3 directions. And your clearance heights as well. Toolpath parameters, this is where you'll control your step over. You also have the ability to control the step over in terms of the scallop height. And these are actually mathematically related. So if I change this to 20 thou, you'll see that the scallop height also changes. And again, they're related with the assumption that you're using a ball nose tool. So that is actually the height of the cuts that would be left behind. Under sorting, you can control the direction of the cut, in this case cutting method, and then as soon as I choose anything other than zigzag, I get the ability to control the direction of the cut. I have the ability to control the order of the cut and machine by either lanes or regions. And if you look in the bottom left corner, you'll see that lanes goes over all the surfaces selected. If I go to regions, it'll recognize regions that have developed. In this case, there's a break right here. Maybe there's a discontinuity right there. So that's basically why it would break up like that. In this case, let's just go with zigzag. Under modify, depending again on your package, you'll see different options in these windows, but for the HSS Xpress, you'll have some of these basic ones here. And a lot of things you can do here are, for instance, under round corners, if your surfaces meet at a sharp corner or a radius that is smaller than the radius of the tool, you can actually tell it to put in a radius that would smooth out the tool path. Under extend trim, if you wanted the tool to go off the surface a little bit, maybe cut some air for the purposes of clearance or lead in, lead out or anything like that, you can use trim and extend and actually extend the surface in a tangential direction or side direction. Toolpath control is not used in the HSS toolpath. This interface is similar to the multi-axis toolpath, so this is where you would actually see control over the tool axis of in the 5-axis toolpath. So here, really all you're doing is just telling InventorCAM which part of the tool you would like to have in contact with the drive surface. Under link, you'll control your lead in, lead out uses. So in this case, at the first entry and the first exit, if I'd like to use a lead in, lead out, and gaps along the cut and links between slices. Gaps along the cut are what you'll see here is as we're zigzagging back and forth, this will be a gap along the cut. As it's going across the surface, it will encounter these slots. So that'll count as a gap along the cut. If it is a small gap, it'll just go right direct across that open air. If it's a large enough gap, it will retract to the clearance area. And those are the default settings. If I wish, I could actually change this to various settings here. And again, depending on which package you choose, you'll have different options. Links between slices are at the very end of the surface. So in our case, if we're zigzagging back and forth, as we get to the edge of the surface along here, what does it actually do? Now, if the motion to the next slice is small enough, it'll be a direct movement. If it's a large enough gap, from, let's say, a very sharp taper or something like that, then that counts as a large move. It'll retract to the clearance area to reposition to the next slice. And again, we have many options under each of these to control that. What constitutes a small movement is defined by either a percentage of the tool diameter or a value. And again, with each one of these entries and exits, you can control it to use a lead in, lead out. Now, there's a lot of references to lead in, lead out in that screen. You actually define it here. Because, again, this is a three-dimensional surfacing toolpath, we have the ability to define many types of lead in, lead out. I typically tell customers in the training sessions that I do to use the default settings as is, and then generate the toolpath, see if you need to come back and change these things. Next is gouge check. This allows me to choose additional sets of surfaces to check against. Check to see if there's a collision with the tool tip, the tool shaft, the arbor, or the holder. If there is a collision, you choose under strategy what you'd like to do in the case of that collision. So the default setting is retract tool, and you choose which direction you'd like to retract the tool in. The next option, trim and relink toolpath, meaning that as you see in the bottom left corner, as soon as the toolpath encounters the check surface, it will actually trim out that bit of the code that causes the gouge and re-begin somewhere else, relinking it. And you can actually tell it where you'd like to begin again. So for instance, if you encounter the first collision and you want to discontinue that entire slice of toolpath, you can do that. You can either do it immediately after, many options. The last two are stop the calculation completely. So in the calculation of this toolpath, it will discontinue the calculation and give you a warning that there is a collision. Or lastly, fully calculate the toolpath and just give us a readout of the collisions. It can do a collision detection against the drive surfaces by default and check surfaces that you select here. So you can go and individually choose the surfaces like you did with the drive surfaces, or you can click on the button that says all faces adjacent to drive surfaces, meaning that any surfaces in contact with your drive surfaces will be selected as the drive surface. Depending on which package of HSS you have, you'll see various options here. Majority of them on the left side here have to do with using this toolpath as a roughing toolpath. You'll see multi-passes and depths of cut. Now, if I generate this toolpath, we should get a feel for what a linear toolpath looks like and link between slices and gaps along the cut. So because I told it to go 0 degrees from the x-axis, it's actually zigzagging back and forth along that direction. And you'll see that there are actually gaps along the cut and the slices at the very end. So as I mentioned earlier, we'll go back to Toolpath Parameters. Actually, we'll go back to Link and Links. And to account for the large moves, we'll switch this to Follow Surfaces. So the curvature or the angle of the surfaces will be used to create a feed line rather than a retractions to clearance area. Likewise, with the large gaps, we'll use Follow Surfaces as well. And you see that really cleans up the toolpath. At the very edges there, it just follows the surface there. There's no need to retract to the clearance area because we're not trying to avoid anything. Now, those options exist in the full HSS. Depending on which version of InventorCAM you have, depending on which package you have, you may have different options there. But the idea with the Links tab is to control the motion of the tool. Now, let's say we go back to Geometry and change this to 90 degrees. So now we'll see the gap along the cut actually becomes a feed move, and we just jump across that gap right there. So let's do a save and copy. Let me hide that previous toolpath, and we'll switch this to Parallel Cuts Constant Z. So Constant Z, depending on the surface of that you've selected as your drive surface, it may look similar to linear. In this case, it will look similar to linear because simply we have a tapered face. But linear will go in one direction, an angle from the x-axis or an angle that you define. Whereas constant Z will actually do what we would refer to as a waterline cut. So regardless of the shape of the surface, it'll actually create a toolpath that maintains a constant Z movement. And it'll just go down in the Z direction to machine that face or machine that surface. Everything else here is the same, but you'll notice in constant Z, there is no other option. It only moves in the Z direction. All we're doing here is just choosing the drive surface. All the other options will stay the same, and I'll just generate this toolpath. So as you can see, the Z-axis is my tool axis, and I have the same parameters. I have a 20,000 step over. In this case, though, it seems like it's a much larger step over. And that is, again, because this now step over is now only in the Z direction. If we angle this, we can see that it is actually stepping down in Z by 20 thou. But because the angle of that taper, that appears to fan out a little bit. So again, there's the differences between linear and constant Z. Very specific to the geometry that you're choosing, very specific to the type of quality of finish you'd like to leave behind. Any questions on this or anything else in the series of videos, you can always give us a call at 1-866-975-1115, extension 2. You can send us your parts and your questions via the ticket system at solidcamsupport.com, or stay tuned for the rest of the videos in this series of videos. Thanks for watching.